So the purpose of this video is to go over 2.3 number 17, and the purpose of this question is to really stress the squeeze theorem. So if we go to page 77 in your textbook, it talks about the squeeze theorem, and the squeeze theorem states that if we can bound a function between two other known functions, or create functions f of x and h of x, such that g of x is always in between f of x and h of x for all values of x near an a value, then we can conclude that the limit as x goes to a of the lower bound, if that equals L, and if the limit of x approaches a of the upper bound equals L, then we can conclude that the limit at the middle function at x going to a is going to also equal L. And the biggest application of the squeeze theorem is the limit as x goes to 0 of sine of x divided by x. This is going to be 1. This is a very powerful limit. At this point in time, you can memorize it and just know it. You don't have to prove it. The proof is actually in the book on page 78 and 79, where they take the sine of 1 over x here is going to be bound by minus 1 and 1, because sine of anything is bound by minus 1 and 1. So if I manipulate this expression by multiplying through by x squared, I can further on have the graph look like something like this, being able to use some limits that I know, and then I can apply this going further, and I can end up with the two important limits that come out of this section. This problem is just kind of having you apply the squeeze theorem. So you can use a online graphing calculator. Demos, the calculator that is linked in the syllabus, is a good one to start. I can put in my first function, which is the red function here. My second function would be the blue function, and my third function being the green function, and you can see what that looks like. So you should be able to zoom in and kind of see what's going on there. So going to the examples, you can see that C here is the correct one. And then plugging in the following limits, the limit as x goes to 0, well, this whole term is going to go to 0, the limit's going to be 1. The limit as x goes to 0 of 1 is simply 1. So applying the squeeze theorem would give you that the limit as x goes to 0 of sine of x divided by x is 1. So that's kind of working through that process. If you have any other questions, please let me know.